Welcome to our lecture on measures of central tendency and variability. In this presentation, we will explore key statistical concepts used to describe and analyze data. I'm Dr. Viktor Burlaka, and I look forward to guiding you through these fundamental measures. When working with data, it's essential to summarize and describe its key characteristics. This is where measures of central tendency and variability come in. Measures of central tendency help identify the center or average value of a data set, while measures of variability show how spread out the values are. Together, these tools allow us to understand and interpret data more effectively. The mean is one of the most commonly used measures of central tendency. It is calculated by summing all values in a data set and dividing by the number of observations. For example, if we have six numbers, 4, 8, 6, 5, 3, and 9, the mean is computed by adding them together and dividing by 6, which gives us 5.83. The mean provides a useful summary, but can be affected by extreme values, or also called outliers. The median is a middle value in a data set when arranged in ascending order. Unlike the mean, the median is not influenced by extreme values. For example, in the data set 2, 3, 7, 8, 10, the middle value is 7, making it the median. When there is an even number of values, the median is average of the two middle numbers. For example, in this data set, 2, 3, 7, 8, 10, 12, the median is 7 plus 8 divided by 2, right? And that'll be 7.5. The mode is the most frequently occurring value in a data set. It is useful when identifying the most common outcome in a data set. For example, in the data set 2, 3, 3, 5, 7, 8, 3, the number 3 appears the most times, making it the mode. Unlike the mean and median, the mode can be used for both numerical and categorical data, such as finding the most common category in a survey. Measures of variability help us understand the spread of the data. A data set where all values are close together has low variability, while a data set with values spread far apart has high variability. The key measures of variability include range, variance, standard deviation, interquartile range, and mean deviation. These measures help us assess data consistency and reliability. The range is the simplest measure of variability. It is calculated as the difference between the highest and lowest values in a dataset. For example, given the numbers 5, 10, 15, 20, 25, the range is 25 minus 5 equals 20. While easy to calculate, the range is highly affected by extreme values, which can make it a less reliable measure of variability. Variance measures how far data point is from the mean. It is calculated by finding the square differences between each value and the mean, then averaging those differences. In our example data set 4, 8, 6, 5, 3, 9, we first find the mean, which is 5.83. Then calculate the square differences from the mean, sum them, and divide by the number of observations to get a variance of 4.97. A higher variance indicates greater dispersion of values. Standard deviation is the square root of variance and provides a measure of data spread in the same units as the original values. If our variance is 4.97, the standard deviation is square root of 4.97, and which is roughly 2.23. The smaller the standard deviation, the closer the values are to the mean. Standard deviation is commonly used in research and political applications because it is easier to interpret than variance. Mean deviation is another measure of dispersion that considers the absolute differences between each data point and the mean. It is calculated by summing the absolute deviations from the mean and dividing by the number of observations. In our dataset for 86539, the mean deviation is 1.97. Unlike variance, mean deviation does not square the differences, making it a more intuitive measure of spread. Why should we care about measures of central tendency and variability? These concepts help us summarize large data sets, compare different data distributions, and make informed decisions. In research, business, and real-world applications, understanding data distribution allows for better predictions, improved quality control, and more effective decision-making. Mastering these statistical tools is essential for analyzing and interpreting data accurately.